Hello and welcome back to another tutorial. Today's video is going to be about how we use division exponent rules. Okay, so before getting to the actual division exponent rules, I just have a really important announcement that if you have not listened to the Jonas Brothers' new song yet, you really need to. It is so good. I have been a huge fan of the Jonas Brothers since I was in 8th grade. Let me insert a picture here when I went to their concert. Here is me in 8th grade at the Jonas Brothers concerts. Oh my gosh, I was so in love with the Jonas Brothers. Just an idea for how long ago this was. Look at this camera back here. Yep, no cell phones with cameras. We used actual cameras back then. But okay, just imagine your favorite group or singer right now. All of a sudden, in 11 years, they come back again. So exciting, and I love their new song, so yeah, check it out if you haven't yet. Okay, anyway, let's get to the math. Let me know if you've heard their new song and how much you love it too. Anyway, our first rule is going to be the quotient of powers rule, and this is how this rule works. If you are dividing exponents that have the same base, and they are raised to an exponent, what this equals is that base to the power of the subtraction of the two exponents. So let me show you an example with actual numbers. 6 to the power of 5 divided by 6 to the power of 2. This would equal the subtraction of the two exponents. So 6 to the power of 5 minus 2 is 3. So again, I think it's important that you know why this rule works. So I'm going to show you a quick demonstration. 6 to the power of 5. This equals 6 times 6 times 6 times 6 times 6, so multiplying 5 sixes, divided by 6 to the power of 2, so 6 times 6. When we have multiplication, what cancels out multiplication is division. So if we are multiplying these numbers in the numerator and the denominator, they cancel when we divide them. So I have a 6 and a 6 cancel, a 6 and a 6 cancel, so I'm left with 6 to the power of 3 over 1, or just 6 to the power of 3. So that's why this rule works. Okay, so here is a little bit of a longer example. So how it works is we are going to combine the exponents that have the same base. So for example, the a's we can combine. So on the top here we have a to the power of 9, and in the denominator we just have an a. And remember, if it's just the variable by itself, that means we have an exponent of 1, that invisible 1 in there. So in total, I would have these cancel, and we're left with 9 minus 8. 9 minus 1 is 8. So we have a to the power of 8. Then we can do the same with the b's. These would cancel. 4 minus 2 is 2. So we have b to the power of 2. Then the c's, these are the only c's, so they do not cancel with anything else. So we'll just leave it how it is, c to the power of 3. And then we can also divide the numbers. They're just straight up numbers, they're not exponents or anything, so we can just go ahead and divide them. 12 divided by 4, that's 3. So just to recap that, what I did is I went one letter at a time and I subtracted the exponents because we're dividing to simplify to just have one exponent with each base in total in this expression. One more quick thing I want to highlight with this rule is in this other example here that I just wrote, this rule does not work. And the reason why it does not work is because in this example we have addition. So we are adding the x's and the y's, we're not multiplying them. Remember, division only cancels multiplication. So if we have addition, it does not cancel with division. So in this case, we cannot use the quotient of powers rule. Okay, so our next rule is the power of a quotient rule. This rule is very similar to the power of a product rule, where if we are dividing two numbers inside the parentheses and everything is being raised to the one exponent, this exponent can be applied to both numbers or variables in the division problem. So a divided by b all to the power of m equals a to the power of m divided by b to the power of m. So to show you an example with variables and an actual exponent, x divided by y all to the power of 3 could simplify to x to the power of 3 divided by y to the power of 3. So I want to quick explain why this rule works. I think it will help you to remember the rules better if you know why they work. So x divided by y to the power of 3, this means x divided by y times x divided by y times x divided by y. So when we're multiplying fractions, we can just multiply the numerators and multiply the denominators. So x times x times x, that's 3 x's we're multiplying, so x to the power of 3. And on the bottom, y times y times y, that would be y to the power of 3. So that is why this rule works. Let's take a look at a couple longer examples now. I'll do this first one to show you an example of how it works. So 3 times p to the power of 3 divided by 7 all to the power of 2. So since everything inside the parentheses is being raised to the power of 2, this power of 2 applies to everything inside the parentheses. So in other words, we would have 3 to the power of 2 times p to the power of 3 to the power of 2 divided by 7 to the power of 2. So I just took this 2 and I applied it to everything inside the parentheses. So then we can go ahead and simplify this a little bit. So 3 to the power of 2, 3 times 3, that's 9. P to the power of 3 to the power of 2. Remember, when we have an exponent raised to an exponent, we can multiply them, because this is really like p to the power of 3 times p to the power of 3. So that would be p to the power of 6. 3 times 2 is 6. We have 6 total p's that we are multiplying there. And then on the bottom, 7 to the power of 2 is 49. Then we cannot simplify this anymore because there's no common factors between 9 and 49. So this here is our final answer. If you want right now, you can pause the video, try the next one on your own and check your answers. If you need a little hint, I'm going to go ahead and explain that now. So pause the video if you want. I'm going to go ahead and explain this now. So I take my power of 3 and I apply it to everything inside the parentheses. So I would have 2 to the power of 3 times x to the power of 4 to the power of 3 divided by x to the power of 3 times y to the power of 2 to the power of 3. So to simplify this, 2 to the power of 3, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. X to the power of 4 to the power of 3. I'm going to multiply these together. 4 times 3 is 12. Divided by x to the power of 3, y to the power of 2 to the power of 3. 2 times 3 is 6. Now I'm going to simplify this. We are dividing here x's divided by x's. So I can simplify this using our division rule, where we subtract the exponents. 12 minus 3 is 9. So here this would equal 8 times x to the power of 9. There are no other y's to combine, so we'll have to leave it as y to the power of 6. The final rule that we are going to be learning is the zero exponent rule. How this rule works is if you have any number or variable raised to the power of 0, that equals 1. Always it equals 1. Let me give you a quick explanation of why this rule works. So let's say, for example, we have a to the power of 4 divided by a to the power of 4. Well, I know that a to the power of 4 is a times a times a times a, the same on the bottom. And when we cancel them, a divided by a, well, anything divided by itself is 1. So a divided by a, that equals 1, times a divided by a, that's also 1, times another a divided by a is also 1, times another a divided by a cancels and also turns to 1. 1 times 1 times 1 times 1, that equals 1. Another way that we could have solved this problem is if we have division of exponents, we can solve this by subtracting the exponents. So a to the power of 4 minus 4 is 0, a to the power of 0. And I've already seen that by expanding this expression out, it equals 1. So one way to solve it, we got a to the power of 0. And the other method of solving, we got 1. So these two are equal to each other for that reason. Okay, here are 3 examples of the 0 exponent. Take a second on your guide and write down what these 3 expressions would equal. You should have 1 for all of them. It doesn't matter how long the expression is inside, how long or short it is. Whenever we take something and we raise it to the power of 0, it always equals 1. Okay, to end this video, here are 2 expressions that combine all the rules together, besides the 0 exponent rule, but the other 2 rules and a few from multiplication. So pause the video in a second, solve these, and when you think you have it, you can go ahead and play the video. These are the 2 answers that you should have gotten. If you got them and you understand this, you can go ahead and stop the video here and start working on the problems for homework tonight. If you didn't get it or you want to see an explanation of how I got these, I'm going to go ahead and explain these answers right now. So our first step is when we have something, a big group of things raised to an exponent, the first step is to get rid of this exponent by applying it to everything inside the parentheses. So to rewrite this, it would be 4 to the power of 3 times p to the power of 4 to the power of 3 times r to the power of 4 to the power of 3 divided by 2 to the power of 3 times p squared to the power of 3 and times r squared to the power of 3. Then we can simplify this. So r to the power of 4 to the power of 3 is 4 times 4 times 4. 4 times 4, 16. 16 times 4 is 64. P to the power of 4 to the power of 3. I multiply these two together. So 4 times 3 is 12. I'll do the same with r. So it'd be r to the power of 12 divided by 2 to the power of 3. That's 2 times 2 times 2. 2 times 2, 4, times 2 is 8. P to the power of 2 to the power of 3, I multiply them to get p to the power of 6, times r, again 2 times 3 to the power of 6. Next, I simplify this. So I'll start off by dividing the numbers. 64 divided by 8, I can actually divide that. 64 divided by 8 is 8. P to the power of 12 divided by p to the power of 6. 12 minus 6 is 6. Then r to the power of 12 divided by r to the power of 6. Again, I subtract my exponents. 12 minus 6 is 6. So that's how I got that answer. Then the last one, I started off the same way. I'm applying this exponent of 4 to everything inside the parentheses in our division problem. So 2 to the power of 4 times r to the power of 5 to the power of 4 times w to the power of 3 to the power of 4, r to the power of 4 to the power of 4, w to the power of 3 to the power of 4. So first, this is 2 times 2 times 2 times 2, 2 times 2, 4, times 2, 8, times 2, 16, r to the power of 5 to the power of 4, I multiply them to get r to the power of 20, and w to the power of 3 times 4 is 12, divided by r to the power of 4 to the power of 4, 4 times 4 is 16, and then 3 times 4 is w to the power of 12. Then I simplify this. There's only one number, so I'm not dividing it by anything, so I just keep the 16. Then I divide my r's. So since I'm dividing them and they have the same base, I can subtract the exponents. 20 minus 16 is 4. Then w to the power of 12 divided by w to the power of 12. 12 minus 12 is 0. So this here would be w to the power of 0, which I know equals 1. And so technically we could write times 1, but we don't really need it. Multiplying a number or an expression times 1 doesn't change the value, so it essentially just cancels out. We have 12 w's on top and 12 w's on the bottom, so they all cancel. We have no w's left. So that is the explanation for these two problems.